Bismillahirrahmanirrahim. Okay, guys, finding the inverse of a function. I'll be telling you this in two parts. In the first part, we shall discuss that what are the conditions that should be satisfied for a function to have its inverse. Okay, guys. So you have to be alert, active, responsive to understand what I am going to tell you right now. Okay, now suppose this is, you people are familiar with these diagrams. There is a function f that maps x onto f of x. Suppose this is 1, 2, 3. There is a, b, c. 1 is mapped onto a, 2 is mapped onto b, and 3 is mapped onto c. So you know that this is a 1-to-1 function, and obviously it is a defined function. There is another example of a defined function, that is, this is x and this is h, maps onto h of x. And suppose you have 1, 2, 3. You can have more than 3 members. I'm just taking examples from here. Okay, this is a, this is b. So 1 is mapped onto A, 2 is also mapped onto A, and 3 is mapped onto B. So this is a many to one function. Both of them are defined functions. Okay, when you write the inverse of a function, what happens is, when you're writing the inverse of a function, what is going to happen is this would be x and this would be f inverse of x. So this f inverse would map x onto f inverse of x. And this over here is going to be now x, and this is going to be h inverse, that is going to map this onto h inverse of x. When you write the inverse of a function, what happens is the domain becomes the range and range becomes the domain. Let me give you a very small example before we drown into this topic of finding the inverse of a function. Suppose you have y is equal to 2x plus 1. Okay, you have y equal to x plus 1, and you substitute x as 0, you get 1. You substitute x as 1, you get 3. You substitute x as 2, you get 5. Okay. Now, if you change the subject of the formula over here, this would become 2x plus 1, that is equal to y. This is going to be 2x equal to y minus 1. And x is going to be y minus 1 over 2. Okay. Now, before this, we wrote this, we made this x the subject of the formula here. This y was dependent onto x. You had the values of x and then you got the corresponding values of y. So this x was your domain and this was your range over here. Okay. Now you have this x depending on your y. So the values of y will now be the domain. Okay. So you will be substituting, suppose you substitute your y as 1, 3, and 5, and see what do you get x as. When you put y as 1, you get x as 0. This is going to be 1. This is going to be 2. So now this is your domain over here. Okay. So you see, this was y in terms of x, and now this is x in terms of y. If you remember your O-level functions, when you were writing the inverse of a function, you were basically changing the subject of the formula of that function. Okay, so one thing that you notice from here, that when you write the inverse of a function, the domain and the range, they are just swapped, they are interchanged. Okay, the domain of a function, please note it down, the domain of a function is the range of the inverse of that function. And similarly, the range of a function is going to be the domain of the inverse of that function. You can see this thing happening in these two diagrams over here. If you look at the top, this x is mapped onto f of x. So 1, 2, 3, these are the members of the domain, and their corresponding members are this a, b, and c. Okay. When you write the inverse, so now this range over here is now the domain, because this is representing x. The one which represents x, that is the domain. Okay. So now this has become the domain, and these are the images, and these are going to be this set is representing the range over here. Okay. Acha. Now, what happens when you have when your range has become domain and domain has become range? Is this still a defined function or not? Yeah, I'm asking from you people. Yes, what do you say? Is this Eman Afaq or Asma or Ozgul? Is this still a defined function? Anyone? Yes.
Yes.
This is a defined function. Okay. Now look at this one. Here you have, this is your domain over here. And now this has become the domain. And now A is being mapped onto 1, A is also being mapped onto 2, and B is being mapped onto 3. Now, is this a defined function?
No.
No, this is not a defined function. So it means this is our hero, okay? One-to-one function. We can only, please note it down. Please note it down that we can only write the inverse of a function. We can only, we can, let me write this as well. We can only write the inverse of a function if it's a one to one function. If it's a one-to-one function. Okay. So that is a condition that should be satisfied. If you want to write the inverse of a function, it has to be a one-to-one function. Otherwise, you can't. Otherwise, you cannot. Okay. So remember, when you have to write the inverse of a function, it has to be a one-to-one function. Okay. Now let me give you some examples here. Now, suppose you have a function, there is f of x. Let me have its in completed square form. This is x minus 2 whole squared plus 3. And your domain is all real values. Okay. Now, can we have the inverse of this function?
No.
Why not?
Because it's a one-to-many function. The inverse will be a one-to-many function.
No, no, it is not one to many, it is many to one function. It is many to
The
one.
inverse will be
Yeah,
many.
yeah. So in its simplest terms, you must say that we cannot have the inverse of this function because this is not a one-to-one function. Why it is not a one-to-one function? Because it has a turning point in the given domain. That's it. It has a turning point in the given domain. Now suppose you have another function g of x, it is x minus 2 whole square plus 3. And its domain is x is greater than or equal to 2. Now, tell me, can we have the inverse of this function?
Yes.
Yes. Now we can have the inverse of this function because if I show you its sketch, I'll show you this in pink. Okay. Now, this is the point here. This point is 2 comma 3. Okay. So if you look at, if you remove this part which is out of the domain, you will see that, like if I remove this part from here, so this is the function that we have right now with us. Okay, so this means that yes, we can have the inverse because it will pass all those horizontal line tests. Okay, it is a one-to-one function because the domain, though this turning point is there in the domain, but this turning point, this is turning point and above that turning point, and you see this turning point does not affect it being a one-to-one function. Okay, if the domain was instead x is greater than or equal to 1 or x is greater than or equal to 0, then we could not have the inverse because it would be like this, the curve would be like this. Okay, and you see this will not be passing the horizontal line test. Okay, so a function can only have its inverse if it's a one-to-one function. In other words, there is no turning point in its domain. Okay, I'll be going back to that question number 15 that you guys were asking. Let me go back to the this question here, question number 15. Okay, it says express all of this in the form. Let's do that quickly. Now, this was the question F in the 15th question. So since this is about this one-to-one function and we are talking about the function to be one-to-one. So it says find the least value of k for which the function is one-to-one. Believe me, you will have, you can see so many questions in your past papers where the question would be stating, find the least value of k for which the function can have its inverse. Okay, the question would say, find the least value of k for which the function can have an inverse. Okay, so it says x is greater than or equal to k. Can I say my domain can be x is greater than or equal to -5? Hmm?
No.
Because if you say -5, so you will be considering this part of the, like, going from this and this. So the turning point comes in between. So this is the border line over here. If you have to use this sign over here, so you will say that x should be greater than or equal to -1. That is the limit. That is the smallest value of x you can have, or this k you can have. Okay, so x should be greater than or equal to -1 if this function has to be a one-to-one function. Do you get this point or not? Hmm? Please tell me.
Yes, sir.
Yes. Okay. Now, the same question could also be asked like this. For this, like suppose now you have here this sign is reverted. Like you have x is less than or equal to k. And now the question is find the greatest value of k for which the function is one-to-one. So then you will be considering this part, okay? And it would be,
सर आपने x is more than and equal to -5 क्यों लिखा है? वो -1 नहीं होना चाहिए
वो यहाँ
या
पे
कोई और सवाल करने हैं?
इसी का I took this example here, like I was taking this point and I was asking you that if this was the domain, then could this be a one-to-one function? And you people answered me that we cannot have one-to-one function if this is the domain.
Okay,
Okay, na?
okay, okay.
Okay. Now, when it says x is less than or equal to k, so it means you have to go backwards. For example, if you have your x equal to, let's say, 3 over here. So if it is x is less than or equal to 3, then you will be considering this part of the curve. Okay. So can we have x less than or equal to 3 and still this function be a one-to-one function?
No.
No. So again, this is the limit. If you have to use this, so then for this condition, x should be less than or equal to -1. And then this -1 would be the greatest value of k because we're going backwards. Okay. So if the question said, find the least value of k for which the function can have its inverse. So this was your answer. Okay. For this given question. Okay, so that was the first part of our lecture of the day where we have discussed that when can we have an inverse, okay? And I would rather be okay, I'll keep another session for separate session for the sketching thing, okay? So we can only have the inverse of function if our function is a one-to-one function. In our next segment, I'll tell you how to write the inverse of a function.